Well, it's been 3 weeks since the nuclear accident, and here's a look back at what's happened to the Fukushima plant so far.
A magnitude 9 earthquake struck Japan's northeastern region, followed by tsunami waves over 20 meters high.
原子力緊急事態宣言が発せられました。
The Fukushima Daiichi nuclear power plant was rocked by the earthquake, knocking out the main power sources for its 3 operating reactors. The tsunami then damaged the plant's backup power supplies. Without electricity to power the water pumps, the reactors were unable to cool the fuel rods. As the exposed fuel rods overheated, the water evaporated further, leading to probable damage to the fuel rods in reactors 1, 2, and 3. The exposed rods generated a massive amount of hydrogen, causing explosions in reactors 1 and 3. After the explosions, radioactive substances were detected outside the plant compound. To prevent further leakage of radioactive substances, Japan's self-defense forces and fire departments have been pouring water into the reactor buildings. Radioactive substances have also been detected in seawater near the power plant. 3 weeks after the earthquake, the situation remains unpredictable.
Earlier, NHK World's Jin Otani spoke with Professor of Nuclear Engineering at the Research Laboratory for Nuclear Reactors at Tokyo Institute of Technology.
We're joined in the studio by Professor of Nuclear Engineering at the Research Laboratory for Nuclear Reactors, Tokyo Institute of Technology, Minoru Takahashi.
Professor, thank you for joining us. So, Professor Takahashi, nuclear power plants were considered safe before. Why has this issue become so serious? Well, with light water reactors, they were considered to be small and safe, and the only accident that was considered in the past was a loss of coolant accident. So they had multiple power systems in place. They had never expected the redundant power systems to become unavailable. This accident occurred not because of a loss of coolant, but because they lost their main and secondary power systems. They lost the ability to move their pumps to remove decay heat. That's the issue. What do you think of the measures taken after the accident? We have reactors 1 through 6. Reactors 1, 2, and 3 shut down immediately after the earthquake. Reactor number 4 was not operating at that time. 5 and 6 were going through periodic inspections, so only reactors 1, 2, and 3 had issues. There was also spent fuel in the spent fuel pool. They also give off decay heat, so all of these spent fuel pools also need to be cooled. For 1 through 3, especially with reactor number 1, there wasn't enough cooling done, so that was an issue. We would like to look at a timeline of events. When the tsunami swept through, the plant lost electricity at 15:41. And then 3 hours and 20 minutes later, their emergency condenser came on. So this actually condensed the steam. However, after 9 hours of staying in operation, the cooling stopped at 4 a.m. the following day. And then at 9 p.m. or 2100 hours, there were 17 hours when no cooling occurred. At that point in time, they decided to inject seawater, but that is very, very late. Decay heat is great. Immediately following an accident, it's usually 6 to 7%. After 2 or 3 hours, it goes down to 2 or 3%, and then in another few days, it goes down to 0.3 to 0.8%. So cooling needs to be continued throughout. If sufficient water is not injected in the early minutes after an accident, the reactor core might be exposed. They were not able to do that, and it was important to have done that. So 17 hours was too long. That's correct. This accident is a result partly of a delay in the countermeasure efforts. Was there any issue with their safety management system? Well, they lost power, which was certainly unexpected. So at that phase, they need to go into accident management mode and really recover from the accident. They need to provide cooling water and emergency power as soon as possible. They also need a good communication organization in place because injecting seawater will have a huge impact on the reactor. So that is a decision that needs to be made smoothly. Their emergency organization structure is not sufficient. We will need to improve that area. And by learning from this experience, I believe that it will be possible to use nuclear power safely.
Tsunami was unassumed, and there are no manuals against the tsunami, and also that there are no training conducted, so that we have to learn the lesson from this and have to grapple with this accident. That's very correct. The works to restore the cooling systems have been very difficult, to say the least, for the past 3 weeks. What do you think that the status of the reactor core, Professor? The overheated sheets of the fuel rods of zirconium alloy reacted with the water and emitted hydrogen. The hydrogen explosion took place, and the leakage of the radioactive substances has been observed, and therefore that the fuel rods are suspected to be substantially damaged, melted, molten even. And at the very early stage, that the heat was emitted. However, that the heat generation is subsided, and that the water is injected to cool this. That we have to maintain this status so that the water injection for cooling and the temperature control both are necessary on a very delicate balance. But too much of the injection of the water is detrimental to the system, and also that the critical state is feared. Well, depending on the situation of fuel, that the recreation of the critical state is something that we have to be cautious against. The boric acid is included into the water to absorb the neutrons. However, that also the control rods are inserted. However, that depending on the situation of the fuel, the water is injected too much, that there may be that the exciting state of that reactivating of the nuclear fission. However, on the other hand, we have to keep injecting the water to cool, so this is a delicate balance. And after that, from the critical point to 3 months or 6 months and 10 years, that what will be to deal with the reactor? Of course, we have to remove the fuel rods which are damaged, and also have to restore the damaged equipment. It takes time and effort, and we have to concentrate the technology, have to expedite this kind of the recovery operation. And plus that there are that high contaminated or low contaminated, that the radioactive contaminated equipment, we have to sort this out and have to make the plan or deal with these remaining equipment. And the Fukushima incident have been triggering the mounting criticism against the nuclear power plant. Do you think that the nuclear power generation plan will be changed? Of course, the nuclear power generation has this kind of the latent risk. However, having said so, that the human beings have to fight against the possible global warming and have to keep on using that energy. And the nuclear energy is a very efficient source of the energy. So that after solving this issue, unfortunate accident, we have to take advantage of the nuclear fission energy for the benefit of the human beings, which is something that we can expect. This is not the end, but taking this opportunity that, Professor, you are saying that we have to accumulate the know-hows and have to create the technology even better and safer. Exactly, that's the way that we should advance. Thank you, Professor.
Minoru Takahashi, professor at the Tokyo Institute of Technology.